Please check those and let me know if you have questions as we go, okay? And then after we discuss this, we're going to be doing the first section of chapter 5. Remember that on number 4, this is not an exterior angle. Why is this not an exterior angle?
Because two sides are extending.
Right. So remember, an exterior angle has to be formed. Sorry, my footage is. An exterior angle is formed by the extension of a side of a triangle and an existing side of the triangle. So this is vertical to one of the interior angles. If it's an exterior angle, how should it be related to the interior angle? It won't be vertical to it. It'll be what?
Equal to the sum of the two exterior angles.
Okay, so it is the sum of the two remote interiors, but this one is vertical to this interior angle. If it's an exterior angle, how is it related to the angle over here?
It's adjacent.
They're supplementary.
Okay, and more than that? Adjacent and supplementary is
a linear pair.
a linear pair. Okay. I'm going to kind of keep track as you guys are answering questions. So I've heard from Nicholas Schneider and Philip and Leah Craver and Alexis. Anybody else just talked to me that I didn't say? Okay. So for number 4, just make sure you're not trying to use that as an exterior angle, because it's not. Okay. Other questions on that problem? Those 4 problems? It did ask you to find on this one, find the length of the triangle's legs. So you should have plugged it back in for that one. Okay.
This is Hastings. On the bottom right not possible one, could that not be side because when all the angles are congruent, aren't the sides congruent? Isn't that like a rule?
So remember, if all the angles are congruent, they might be similar but not congruent triangles. So if you don't know any side lengths, it's actually possible for the sides to be proportional but not be congruent. So they're kind of drawn to look congruent to try to throw you off. But yeah, if you know that this only angles, you can't say they're congruent. Now for the last one. Go ahead.
For the third one with the parallel lines,
yes.
Can't you tell that the other, like the ones next to the two congruent angles, can't you tell those are congruent too?
So if I stretch out the parallels here and use just one transversal, so if I use like this transversal, for example, that will give me these 2 angles. Okay, it's not going to give you the angles over here because those are using those 2 lines, not just the parallels and the transversal. And this one's using those 2 lines, not using the parallels and a transversal. So with that one, you actually only have one transversal that will give you any angles in the 2 separate triangles. So if you try to just kind of ignore these because you need two parallels and one transversal at a time. Those triangles are actually not congruent.
Okay, thank you.
Be careful that on ones like this, that whatever markings you have correspond to the answer that you have. So if you said hypotenuse leg, then having that would be fine. If you said side, 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 you'd have to have at least that. Okay, if you said side angle side, then I guess you'd want it that way as well. Okay, so just make sure that your markings, if you say side, 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 but you have that, that's not correct based on the markings. Okay, that's HL. So make sure you're marking the picture. That's something that students do not, for some reason, just kind of naturally do. I don't know why, because my first instinct is to draw on the picture when I have a picture. So make sure you're showing me the parts on the diagram. Okay, so for the problem at the bottom, there's actually two of those that you cannot give answers to. So angle 6 and angle 5, you actually cannot figure out from what you're given there. And that would again be because like those two, although they're alternate interior with these lines and that one transversal, those lines aren't parallel. So you cannot actually figure out those angle measures. Okay, so these angles have to be congruent, but those do not. Okay, any other questions on the first page? Okay, here's the second page.
Ms. Hastings,
Yes.
is the included side just the side that's between the two angles?
Yes. Included means it's formed by those two angles. Yes. So when you say like angle, side angle, the included side is the ones between the two angles. That's what I'm trying to get you to think about. Okay. These answers for distance formula for PQ, those should be simplified. Root 18 and root 8 both break down. Questions on 7 or 8? Okay, there's 9 and 10. So for this one, you're actually looking at proving this triangle and this triangle are congruent. So you're using the big triangle ARQ as isosceles, but you're not doing anything with the big triangle. You're using the two small ones.
Wouldn't Y in number 10 be 14?
Yeah,
I
I
was
was
just
gonna
gonna
say.
say,
Good word by this.
And then wouldn't that make X 8?
it's gonna change that answer. We were just looking at that problem in my academic class earlier, and I was like, wait, I thought that was supposed to be 14. Yes, that is a mistake. Okay, and so that's gonna throw off this one because that should be 14. So 24x is 8. Thanks. Who was that? Was that Jack?
It was me.
Okay, thank you. I was looking down. Okay, questions on 9 and 10? All right, I told you to skip number 11, so that gets kind of complicated. Like I said, it's using two different pairs of triangles. So this one, you have to use a pair of triangles to get more parts to prove another pair congruent. So I told you to skip that one because we're not going to do ones that complicated. Okay, there's the proof for number 12. Remember, I think there's only one person who did this, but remember, you always can put on a picture like that. You can do like 1 and 2 and just say angle 1 is congruent to angle 2 here. So you don't have to worry as much about the order of the letters. So if sometimes I don't put numbers on there because I don't want to sort of like lead you to say something in particular, but you can always throw numbers on there to talk about angles and proof. Questions on that proof?
I have a question just in general.
Okay.
Like on the last one for number 5 for the reason. On the test, if we're writing like definition of congruent angles, can we just write that, or do you want us to write the corresponding parts are congruent?
Okay, I just want to make sure you said angles, but you meant
Or
triangles.
triangles, yeah, sorry.
You can just say that, that's fine. You can just say
Okay.
this, that's fine. You can write both. I usually write both just so you know that they kind of go together. And so if I gave you like that as a reason, you would know that's the same thing as definition of congruent triangles if you're trying to fill in the statement.
Okay, thank you.
So for number 13, you're actually using the definition of isosceles triangle twice. Okay, the definition of isosceles triangle is a triangle that has at least 2 congruent sides. So when you go from the triangle's isosceles to saying that has 2 congruent sides, that is definition of isosceles, and vice versa. If a triangle has 2 congruent sides, then it's an isosceles triangle. Leah, did you want to say something?
Yeah, so for number 7, when you wrote all of that out, could we just say isosceles triangle theorem?
That's actually the converse of the isosceles triangle theorem. So
Okay.
that's why I don't really want you to use that, because I don't want you to have to really worry about which one is the theorem, which one is the converse. So you can always either say in a triangle, if 2 angles are congruent, the opposite sides are congruent, or in a triangle, if 2 sides are congruent, then the opposite angles are congruent. This you could also say as in a triangle, if 2 sides are congruent, then the opposite angles are congruent. But you kind of have to pay attention to, are you given sides or are you given angles? But yeah, I'd really rather you not try to use the isosceles triangle theorem or the converse, because students tend to get confused on which one's which. Okay, questions on that proof? All right, and then the last ones. Your homework is going to be 2 separate PDFs. I didn't take the time to put them together. So just make sure that when you're looking at that you have 2 separate documents there. I would put them into the same, like I would just open the first one and then copy the second one into the same note. But so and then just do one submission. But I didn't put them into the same PDF. So just realize there's 2 separate documents there. Okay, so this whole chapter is going to be talking about special kinds of segments and triangles. So the first one is mid-segments. So a mid-segment is shown in the picture down here. So a mid-segment is a segment that joins the midpoints of two sides of a triangle. So the definition of a midsegment is you have a triangle, you locate a midpoint of the two sides, you join them together, that's a midsegment. Okay, so in this picture, that segment XY is a midsegment. And you have to be starting with two midpoints. Connecting the midpoints of two sides of a triangle creates a segment called a midsegment of the triangle. How many midsegments would a triangle have?
Infinite.
How many sides are there?
3.
3. Okay, that means that there's 3 midpoints to join together. So I could throw one more midpoint here, and then there would be 3 midsegments. Okay, I'm just going to leave that 1 there because I want you to see that as the definition. But you can always draw 2 other midsegments there. Now, that's the definition. Definition is that a midsegment joins midpoints of 2 sides of a triangle. The midsegment theorem. Okay, this is a midsegment theorem. The midsegment is, there's 2 things that are going to be true. You can see one of them shown in the picture here is that the midsegment is parallel to a side of the triangle. It's parallel to the side of the triangle it doesn't touch. Okay, the third side, meaning the one whose midpoints it's not connecting. And then the length of a midsegment is half the length of the side to which it's parallel. So if this were 20, that'd be 10. Okay, the length of the midsegment is half the length of the third side. And again, when we say third side here, we're talking about the one that's not parallel to. So in that picture, segment XY is parallel to segment AC, and XY is 1/2 of AC, or AC divided by 2. Okay, so some questions here. How do you know when you look at this picture that XY, YZ, and XZ are all midsegments? How can you tell from the picture that these are all midsegments?
Is it because both sides are equal on both sides of the point?
Yeah, be a little bit more specific. What do you mean by both sides, Katie?
So for like A and B, or yeah, for A and B on both sides of X, their AX is congruent to BX.
Okay, and so X is what of the segment?
Is the midpoint.
Midpoint, right? Okay, so yeah, because you've got midpoints shown in the picture, that's how you'll know that those are midsegments. So you can see that X, Y, and Z are all X, Y, and Z are all midpoints. Okay, how is XY related to segment AC? How is XY related to segment AC's length? Okay,
It's
Aaron, go ahead.
it's half XY is half the length of the segment AC.
Yeah, XY would be 1/2 the length of segment AC. Now again, I don't have the bar over top of that because it's not the actual segment, it's the length of the segment. Okay, how is XZ related to BY and YC? So in the picture here, how is segment XZ related to BY and to YC?
It's not.
It's not. It is. There's a relationship.
They're congruent.
Thanks, Pablo. They're congruent. So if I were to put markings on this picture, I would put how many markings on that green segment? How many markings would I put on that segment?
2.
2. Okay, because XZ is half as long as BC and Y is the midpoint, that means that BY, YC, and XZ are all the same. How many markings would I put on the purple segment?
3.
3.
Who was the guy who just answered?
Elliot.
Thanks, Elliot. Okay, and so XZ is equal to BY and CY. Are there any congruent triangles in the diagram? Okay, so for the blue segment, if I do the same thing on the blue segment as we did on the other, actually, you know what? I'm gonna use a darker blue here. If I do the same thing on the blue segment that we did on the other segments, how many markings does the blue one get?
1.
It'll get 1, right? It's congruent to that one. Okay, so are there any congruent triangles? Are there any congruent triangles?
All of them, right?
Philip, so when you say all of them, that includes that one?
Except like the big one. I just mean like the 4 small ones.
Okay, tell me how you know the 4 small ones are congruent.
Well, they're all congruent by side congruence.
Yeah. So you actually have 4 congruent triangles here. So there's one, here's one, here's one, and here's one. Okay, so all 4 of those triangles are congruent by side. Okay, the perimeter of triangle XYZ, that's the little like pink one in here. I'm gonna change the color a little bit, make it more pink. So now the purple one looks too similar. Okay. The pink triangle, how will its perimeter compare to the original big triangle? Philip's not allowed to talk.
Is it half?
It's half. Why, Sammy? Sammy, was that a guess or do you know why?
Well, each of the tiny triangle segments are half of the big triangle segment.
Right. So let's say that we knew this whole thing was 12. That would mean that this is 6. Right? If this whole thing was 10, that would mean this is 5. When you add them up, because the little triangle, the little pink triangle, is half the length of a side to which it's parallel in the original triangle, that means that the perimeter, the inside ones, will be half the perimeter of the big one. So the perimeter of triangle XYZ is 1/2 the perimeter of triangle ABC. If the perimeter of XYZ is 36, then the perimeter of ABC would be what?
72.
72. Thanks, Grant. Okay, so here's a few problems. Segment AB is a midsegment. Find the value of X. If that's a midsegment, what's that tell you? How do you know how to find it? Like, how can you find X?
It's half of RT or EF.
I'm talking about this one. In that one, just look at that one triangle. Okay, we're not comparing the 2 triangles. Just look at that one triangle. What does it tell you that that is a midsegment?
Segment DB and BE are congruent.
Thanks, Jack. Okay, so those two have to be the same because a mid-segment means that it's hitting midpoint. So these two would also be congruent, although not really relevant. It's going to be connecting midpoints. So that means that x minus y is going to equal 2x minus 17, and x will be 10, I think. Okay, for the next one, what can you tell me?
2x plus 5 is half of 3x plus 15.
Okay, so Aaron said 2x plus 5 is 1/2 of 3x plus 15. Okay, that's true. That works. Can somebody give me a different way of saying the same thing with a different equation?
2x plus 5 times 2 equals 3x plus 15.
Thanks, Jake. So you can either do that the small one is half the big one, or you can just say double the small one to get the big one. Sometimes it's easier to not have to think about the 1/2. So if you prefer to do doubling that 2x plus 5, that will give you the segment of the big triangle, which is parallel. Okay, whichever way you solve that, you can either distribute the 1/2 or the 2, or you can start by dividing both sides by 2 or multiplying both sides by 2. Kind of depends on what you prefer for your algebra. I'm just going to do this one. I'm going to go ahead and distribute. 4x plus 10 is 3x plus 15, and x would be 5. Okay, so in the next one it says J is the midpoint of segment KL. So I'm going to go ahead and mark that on the picture here. J is the midpoint of segment KL, and H is the midpoint of segment KN. Find the value of x. Dayanara, what would x be?
Would it be 15?
15. Okay, so that segment is half the length of the side of the big triangle to which it's parallel. Okay, and then if the measure of angle L was 80, so if I wrote 80 degrees on that little angle right there, the measure of angle LJH, that's this angle measure right here. Someone who has not talked to me today, tell me what that angle measure would be. There's still a few of you. Abigail, tell me what that angle measure needs to be.
100.
How do you know?
Because JH and LM are parallel, and then the angle L and LJH are interior angles.
What kind of interior? They're not alternate interior, they are
I forget the word.
consecutive interior. Okay, so just keep in mind that everything you knew about parallel lines still applies when you have a mid-segment in a larger triangle because of all those parallel segments. For the notes, we're just doing the first page. Okay, so there are kind of 5 different special sorts of triangles, special segments in triangles. And that's what this whole chapter is kind of focusing on. So first of all, for a triangle, we just talked about mid-segments. So if I showed you a mid-segment of the triangle, would it be okay to draw it like that? Is that a mid-segment? Emma, is that a mid-segment?
Yes.
How do you know it's a mid-segment?
Wait, do you don't have, because it's half of the line, the other line?
Is it?
Oh, wait, no, we don't have any proof,
Okay, so
right?
if I wanted to show a mid-segment, I would need to do that. And also what?
I'm not sure. I thought you just had to have the two congruent parts and then it has to be half of the long segment.
Jake, tell me what else needs to be marked.
The bottom leg, like both sides of the line.
Yeah, so we need to make sure if we're saying that that's a mid-segment, we need to make sure it's joining two midpoints. So its endpoints have to both be midpoints of sides of the triangle. That's the definition of a mid-segment. And then again, the mid-segment theorem says two things. Mid-segments are parallel to the side of the triangle that it doesn't intersect. And then its length is half as long as the side to which it's parallel. Okay, so there's three facts about a mid-segment, but one is the definition and two of them are the theorem. So you kind of want to sort of keep in mind that those are coming from kind of different places. Okay, some of these are terms that we've talked about before and some of them are not. So angle bisector, we've talked about that before. How do I show, I'm going to do an angle bisector here. How do I show that that's an angle bisector? An angle bisector of a triangle is a line, ray, or segment that divides an angle of a triangle into two congruent angles.
You have to show that the two angles, like, of the A, like in between the line, are both congruent.
Okay. I need to mark that these are congruent, right? Otherwise, you'd have to be assuming it's an angle bisector. Now, you may be used to seeing the angle bisector drawn as a ray, but when we're talking about this lesson or this chapter, usually we're thinking about like a triangle and then kind of things that are sort of inside the triangle more. So it could be a segment also. And so there's an example. Does an angle bisector have to bisect the side of the triangle? Is it true that this segment and that segment will be the same length?
No.
Yeah, they don't have to be, right? So those in general will not be the same. They can be, but in general, no. Okay, so just be careful that you're not saying that an angle bisector cuts the side in half. Okay, that's angle bisector. Okay, a perpendicular bisector. A perpendicular bisector is a line, ray, or segment that's perpendicular to a triangle side, and then it also has to go through a midpoint. So it does two things. It's perpendicular bisector. So it needs to go through a midpoint. So I'm going to locate a midpoint here. We're just eyeballing this. So I want to make sure you know that that's meant to be a midpoint. And then what does perpendicular mean? I have not talked to, Melissa, you answered the last question, I think. Josh, I haven't talked to you. And I haven't talked to Nicholas Bearby. What does perpendicular mean?
It forms 90-degree angles.
Okay. So when I draw the perpendicular bisector, will it go through point A, Nicholas? Does it look like it's going to go?
No.
No. So a perpendicular bisector, that was horrible. Let me try that again. I'll go back to it again. Trying to sketch that to appear to be perpendicular. So in order for you to know for sure that I need to make sure I put the markings there. Now we know that that's a perpendicular bisector. Oh, I said segment AC. I should read what I said. Okay, let me back up here. Let's do the same thing for segment AC. So I'm going to find the midpoint of segment AC. There's a midpoint. And then draw a perpendicular. We're just eyeballing it, so it may not look exactly perpendicular, but now you're supposed to assume that it is. Okay, and once I put a right angle mark there, then you know. Okay, does it have to go through a vertex? No, it could, does not. All right, so it does two things, perpendicular, and it has to hit a midpoint. Okay, median. A median is a segment that has its endpoints at a vertex of the triangle and hits the midpoint of the opposite side. So it goes from a vertex to the opposite midpoint. This is a median. Okay, I should read again. It says, sketch a median 2, segment AB. All right, so here's the median 2, segment AB. Those are congruent, so that's a midpoint, and then we're coming from point C. Okay, so that would be a median. It does two things, goes through a vertex and has to hit a midpoint. Okay, midpoint to vertex. And then lastly, an altitude. An altitude is a segment that contains a vertex and is perpendicular to the opposite side. It contains a vertex and is perpendicular to the opposite side. So sketch an altitude 2, segment BC. It has to go through a vertex and it has to be perpendicular to the opposite side. Okay, that's also called the what? Josh, do you know what that is? That segment is the altitude. It's also called what when you're finding area?
I don't know.
Okay, if I did area triangle, remember the area of a triangle formula?
1/2 base times height.
If this is your base, this is your
Height.
height. Altitude is the same thing as the height of a triangle. So when you're thinking about altitude, you can kind of think about that as being the same thing as height. Kind of like when you're like up in the mountains, your altitude is like how high you are above sea level. Okay, we have like 1 minute. So again, just like kind of two things each of these segments has to do. So an angle bisector goes through a vertex and makes two congruent angles. Okay, a perpendicular bisector has to go through a midpoint and also be perpendicular. Let me do this. It has to go through a midpoint and also be perpendicular. That's two things. A median has to go from a vertex to the opposite midpoint. Two things. Okay, and then an altitude has to go through a midpoint and make a right angle with the opposite side. The quizzes, both quizzes for chapter 4 should be visible to you now in ClassKick. So if you log back into ClassKick, you should be able to see your quizzes, and it should be locked so you won't be able to actually like change anything, but you should be able to see them now.